In the space of science and colossal advancements in knowledge, the subject of what existed early on before the immense effect has sparked mixed discussions and fascinated thinkers for a long time. This profound question doesn't simply test how we interpret the universe. It challenges the very limits of human understanding. Envision standing at the edge of existence, gazing into the vast unknown, and wondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of history, space, and everything we know. However, was there a moment before this? Could there have been a state of nothingness, a quiet before the grand emergence? Or perhaps, was there something even more mysterious that existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, exploring ideas that challenge our perception. Physicist Brian Cox, known for his contributions to the understanding of the universe, suggests that something astonishing could have existed before the Big Bang. He challenges us to rethink our understanding of reality and existence. In this analysis, we will break down the science, theories, and astonishing secrets that could explain what existed before everything. We'll explore concepts such as eternal inflation, quantum fluctuations, dark energy, and even the multiverse. The answers we uncover may astonish you, yet they could also provide new insights into our place in the universe. Prepare to dive deep into a world beyond imagination and science, where the unknown still lingers in the shadows, leaving researchers both awed and perplexed. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. According to scientists, the Big Bang was the event in which the universe became extraordinarily hot and dense, expanding rapidly to set the foundation for all matter, energy, and cosmic forces. When we look at the night sky, we see evidence of this fiery beginning, with galaxies moving outward from a central point. But what caused this to happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before. However, it was far from empty or calm. Inflationary theory suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, akin to a vast vacuum. Yet this vacuum wasn't entirely empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. This period of inflation happened so swiftly that it essentially set the stage for everything that would follow. In a fraction of a second, space expanded at incredible speeds until the expansion slowed, and the energy transformed into matter, particles, and the fundamental forces of nature, leading to what we call the Big Bang. But what was the nature of this energy? Where did it come from? And why did it stop? Scientists believe that this immense expansion created different regions of the universe, each experiencing its own Big Bang. Imagine a cosmic fabric stretching endlessly, with tiny bubbles forming, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that there are potentially infinite Big Bangs and countless universes. Our universe may be just one of many. This mind-bending concept challenges how we perceive the cosmos itself and raises the ultimate question: what else is out there? The concept of nothingness before the Big Bang is purely theoretical. In fact, according to our current understanding, even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and fundamental forces. Even in its emptiest state, the universe remains an intricate masterpiece of something rather than absolute nothingness. Even if we strip away all forces, leaving behind a void, the universe would still generate new types of energy. This perplexes scientists because it suggests that absolute nothingness may be impossible. Space itself has properties, laws, and constants that prevent it from being completely empty. Imagine creating a region with absolutely nothing. No particles, no radiation, and no energy, except for quantum fields and fundamental constants. These would still exist, implying that this so-called nothingness still has properties. For instance, there's a concept called zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles can still appear and disappear, creating a faint echo of activity in what should be empty space. This challenges the very idea of a true vacuum and suggests that even before the Big Bang, something existed. Scientists are only beginning to understand this. One of the most astonishing theories in modern cosmology is the possibility of eternal inflation. If inflation can create our universe, it is possible that it continues indefinitely. Brian Cox describes a vast inflationary multiverse where universes are continuously created and expanding. Imagine each Big Bang as a spark igniting another universe while inflation occurs in different regions, generating countless new universes. This cycle could, in theory, go on forever. This concept of universes birthing other universes leads to a fascinating idea, a fractal universe, where each new universe may, in fact, create its own Big Bang. Each universe would exist as an independent reality, unaffected by the others. For researchers, this hypothesis is both exciting and unsettling. It suggests an endless multiverse with no clear beginning or end. Imagine our universe as just a tiny fragment of a massive cosmic web, continuously forming and creating new universes. What if that is the true nature of reality? What if there is no before or after, but rather an eternal pattern of universes forming? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not simply a collection of matter floating in space. Rather, it is a complex network of energy fields filling the cosmos and interacting to create everything we observe. These fields are like invisible oceans, with particles behaving as waves or disturbances. Even when the fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and disappear within these fields, temporarily gaining energy before vanishing again. This characteristic leads to virtual particles, substances that briefly exist and then fade away, leaving only a faint trace of their presence. The idea of virtual particles challenges the concept of true emptiness. Imagine an empty universe where all matter, radiation, and energy are removed. Would you truly have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, quantum fields remain active, sometimes creating fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't conform to our idea of emptiness. The fields and forces persist, filling the universe with latent energy that prevents absolute nothingness. This raises an intriguing question. If quantum fields can generate particles and particles create matter, could the entire universe have emerged from this so-called nothingness? Another fascinating theory, cyclic cosmology, offers an alternative to the Big Bang as the ultimate beginning. This theory suggests that the universe undergoes massive cycles of expansion and contraction, endlessly repeating over time. Instead of the universe emerging from a singular beginning, it continually collapses and re-expands in an eternal process. This challenges the idea of a single creation event and proposes that what existed before the Big Bang was simply another version of our universe in a previous cycle. The cyclic model suggests that after billions of years of expansion, the universe will eventually slow down, contract under gravity, and return to a highly dense state. This contraction would then trigger a new Big Bang, restarting the cycle. If true, this means that time itself has no absolute starting point, only a continuous rhythm of destruction and rebirth. This theory aligns with some interpretations of quantum gravity and string theory, which propose that the universe is shaped by higher dimensional physics. Some scientists believe that the universe's past cycles may have left behind subtle imprints in cosmic microwave background radiation, providing potential clues to its history. The role of extra dimensions and the multiverse. String theory, one of the leading frameworks in modern physics, suggests that our universe might not be the only one. Instead, it posits the existence of extra dimensions beyond the three we experience, possibly giving rise to other universes with entirely different physical laws. According to one variation, the brain world hypothesis, our universe is a three-dimensional membrane or brain, floating in a higher dimensional space. Occasionally, two brains might collide, causing an event similar to the Big Bang, birthing a new universe. This raises the question, could our Big Bang have been the result of two higher dimensional objects colliding? If so, what existed before the collision? The answer might lie in a vast higher dimensional space where multiple universes form and evolve in parallel. Could consciousness be linked to the origin of the universe? A more philosophical perspective questions whether the fundamental nature of reality could involve consciousness itself. Some physicists and philosophers explore the idea that consciousness is not merely a byproduct of the universe, but a fundamental part of its existence. Could the universe have awareness in some form? Could consciousness exist independently of matter? If so, was there a form of proto-consciousness before the Big Bang, shaping the laws of physics? While this remains speculative, some interpretations of quantum mechanics, such as the observer effect, suggest that observation plays a role in shaping reality. If consciousness influences reality, then it may have existed in some form before the Big Bang. The ultimate question: can we ever know what existed before the Big Bang? Despite our growing understanding of the cosmos, the question of what existed before the Big Bang remains one of the greatest mysteries of science. Whether the answer lies in quantum fluctuations, extra dimensions, dark energy, or something entirely unknown, we are only beginning to scratch the surface. Future discoveries in physics, perhaps through experiments in particle accelerators, gravitational wave detectors, or even theoretical breakthroughs, may one day bring us closer to an answer. Until then, the search continues. The quest to understand what came before everything we know is not just a scientific pursuit, but a philosophical and existential journey. Perhaps the true answer lies in perspectives yet to be conceived, in equations yet to be written, or in an understanding of reality that transcends our current limitations. Whatever the answer may be, one thing is certain. The universe, in all its vastness and mystery, continues to inspire wonder, curiosity, and the relentless pursuit of knowledge. In this model, the huge explosion is certainly not a one-time occasion, but rather part of an undying cycle where universes foster, isolate, and then recuperate in another cycle. This hypothesis suggests that our universe could have been re-established from the remnants of a previous universe. The process of pressure and development in a cyclic pattern would mean that there was never a true beginning, but rather an everlasting series of universes emerging, creating, and recharging themselves again and again. Cyclic cosmology raises significant questions, especially now, as it suggests that time itself could repeat instead of continuing linearly. If this hypothesis is correct, it could imply that what existed before the huge explosion was essentially another form of the universe, one that collapsed solely to give birth to our current universe. For scientists, this hypothesis offers a compelling answer to the question of extreme beginnings, suggesting that there is no clear starting point. The universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves and the pre-Big Bang universe. Gravitational waves present another fascinating idea that could shed light on what existed before the Big Bang. Discovered in 2015, these waves are ripples in space-time caused by incredibly massive objects, such as black holes or colliding neutron stars. These waves can travel great distances, carrying information about the events that created them. Could gravitational waves provide information about the birth of the universe? Some physicists propose that gravitational waves from the time before the Big Bang might offer insights into the state of the universe before cosmic inflation began. These early universe gravitational waves could leave traces that help us understand whether the Big Bang was truly the beginning or whether there were cosmic events before it that we do not yet comprehend. If such waves contain hints of a past universe or an event preceding the Big Bang, they could suggest a greater structure beyond what we currently know. These faint signals could unlock crucial information that changes our understanding, just as the discovery of the Big Bang itself revolutionized cosmology. The mystery of what existed before the Big Bang. As scientists continue to explore the vast reaches of space, the question remains, what existed before the Big Bang? Current theories point to quantum mechanics, multiverses, and cosmic inflation, bringing us closer than ever to uncovering the deep mysteries of the universe's origins. While a complete answer remains elusive, our understanding of the pre-Big Bang universe continues to evolve with each new discovery. As we explore these theories, we must consider how they fit together to reveal the bigger picture, the true nature of existence itself. Until then, we are left with the mystery that drives scientific exploration, pushing us beyond known limits. Time, reality, and quantum possibilities. One vital area of investigation involves the relationship between space and time. Time, as we experience it, may not have existed in the same way before the Big Bang. Some theories propose that time, as a dimension, began with the Big Bang, making it impossible to trace what came before. This idea challenges our fundamental perception of existence, suggesting that the question of before may not be meaningful in the context of the universe's origins. Furthermore, advancements in quantum mechanics have sparked new ideas about the nature of reality. One particularly fascinating concept is the quantum vacuum, a state where, even in the absence of matter, the universe is not truly empty. Instead, it is filled with fluctuating energy fields that can give rise to particles and forces. These quantum fluctuations could have played a crucial role in the formation of the universe, potentially providing the conditions necessary for the Big Bang to occur. This raises the question of whether the universe arose from a quantum fluctuation or if it was triggered by some other process. Cyclic cosmology and the eternal universe. Another intriguing aspect of pre-Big Bang theories revolves around the concept of cosmic recycling. In cyclic cosmology, the universe undergoes an infinite series of expansions and contractions. After each Big Bang, the universe would eventually contract back into a singularity before expanding again. This repeating process could mean that the current state of the universe is merely the latest cycle in an endless series of cosmic births and deaths. Some theorists propose that each cycle could lead to slightly different outcomes, with the present universe being shaped by the conditions of the previous cycle. This idea challenges the concept of a singular beginning, suggesting instead that the universe is in a constant state of renewal. Higher dimensions and the origins of the universe. The possibility of multiple dimensions adds another layer of complexity to our understanding of what came before the Big Bang. String theory, for example, suggests the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the universe's origins. In this model, the Big Bang may have been the result of interactions between these higher dimensional spaces. The collapse of a higher dimensional structure could have led to the birth of our 3-dimensional universe. If true, this hypothesis would not only offer insights into what existed before the Big Bang, but also open up new possibilities for how the universe functions at the most fundamental level. The search for the ultimate origins. As we push the boundaries of scientific understanding, it is clear that there is still much to uncover. The quest to answer the question of what came before the Big Bang is ongoing, with researchers continuously advancing technology, developing new theories, and making groundbreaking discoveries. One day, we may come closer to unraveling the ultimate origins of our universe, gaining a deeper understanding of the forces that shaped everything we know. Until then, these questions will continue to inspire awe and curiosity, challenging us to think beyond the known and explore the limitless possibilities of existence.